Okay, so the z-score, again, number of standard deviations away from the mean. Okay, calculate it. X minus the mean divided by the standard deviation.
And what is X?
Whatever score that we're actually looking to find the z-score for. Okay, so first and foremost, we're going to have to find the z-score. With that z-score, that's what we have that table there for. Okay. I'll explain that a little bit more here in a second. Okay, so to start, let's first start to find z-scores. Okay, convert the following data points into a z-score with the given information. So we got a mean of 8 and a standard deviation of 0.5. So let's just do the normal curve here and let's set it up. Okay, what always fell in the middle? The mean, average, right? So that's 8. We get 1 standard deviation away. And if the standard deviation is 0.5, what are those two values? 7.5 and 8.5. We get 2 standard deviations away. 7 and 9. 3 standard deviations away. 9.5 and 6.5, right? Now, the probability of something being outside of those values is so unlikely we don't have to worry about it. Okay, that's at 0.15%, right? So that's how it'd be set up. And again, yesterday we fell right on those standard deviations, right? And then we would just add up those areas, 34%, 13.5%, 2.35%, and then that finally that 0.15%. Now we're falling somewhere in the middle of those. Okay. So now I'm going to start looking for values like 6.9. 6.9, that would fall
Hang on, is that big one 34 or 24?
34. Okay. So 6.9 would fall like right there where that green line is, right? Okay. Does that fall on 1, 2, or 3 standard deviations? It's going to be like 1, 2 point something, isn't it? Okay. So just having that idea will be able to tell you, okay, what will my answer somewhat be? Okay. The other thing too, when I go left of the mean, my mean's at 8 and I go left of that, this is -1, a z-score of -1, -2, -3. So in this case, when we do 6.9, it's going to be -2 point something, isn't it? And that's what we're looking for. So again, the z-score is equal to that x value minus the mean divided by the standard deviation. So our score we're looking for is 6.9 minus what? 8 divided by 0.5. You'll have calculators, type it in. You'll end up getting -2.2. Now, anytime okay, you type in the calculator and it goes beyond the hundredths place, I need you to round to the hundredths place. Because our table here gives us to the hundredths place. So z-scores always round to the hundredths. Okay. 2.20. Now, 8.3. 8.3 is going to fall like right here about, right? So should this z-score be greater than 1?
No.
What's up, ladies?
Can you hold my keys when we go to the back before we go to elementary school? Put it in my desk.
Sure.
Here you go. Sir,
You bring me a donut?
not.
What?
Unfortunately.
shouldn't be greater than 1. It's going to be 0 point something, isn't it? So, again, the z-score is equal to that score minus the mean divided by the standard deviation. Oh, 0.5. So that'd be 0.3 over 0.5, right? 3/5, that is 0.6. Again, you'll have calculators, so you'll be able to type it in. Okay. That's not a full standard deviation away from the mean, is it? And we went right of it, so it will be positive. Okay, finally 9.2. 9.2 is going to fall about there. So 1, 2, we're going to have 2 point something when you do this. Z-score, 9.2 minus that 8 divided by 0.5. That'd be 0.7, 1.2 over 0.5, 2.4.
What, isn't this whole thing like 1?
The whole curve is, yes. So with the z-score, you got to remember though, it's about how many standard deviations we're away. When we start using this, that's when you're going to bring in the idea of 100% or 1. Okay? These next problems, we'll get to what this is all about. Okay. So, a student has computed that it takes an average of 17 minutes with a standard deviation of 3 minutes to drive from home, park the car, and walk to class. What is the probability that it takes the student at most 21 minutes to get to class, assuming the data follows a normal curve? Okay, what's going to go in the middle there? 17. What are those values surrounding it there? 11 and 8, correct? Okay, so now we're going to look at the question. We got our table, or we got our curve set up. Okay. What's the probability that it takes the students at most 21 minutes? 21 is going to fall about here, correct? What's up, bud?
I wasn't paying attention, and now I don't know what the example thing was.
Okay, so we just set up our curve. Okay, we had an average of 17, right?
Yes, but I also missed the first example thing.
Okay.
I mean, I got the 6.9, but not 8.3 and 9.2.
Remind me at the end when we're done with the lesson, I'll go back to it so you can copy it down, okay? Okay, so we got our standard deviations away. Now, if I say at most 21, what's that saying?
21 is the maximum.
That's the maximum. So could I have 9 minutes,
Yeah.
10 minutes, 11? So this is the area that I'm looking for, right? And the area under the curve is what tells us the probability. That's where the whole 1 or 100% comes in. Okay? So this is the area that I'm looking to find. Okay, yesterday they fell right on those standard deviations, and we should know, at this point, we should know those areas, right? But now it doesn't fall on one of those. Okay, so this is where we need the z-scores, because it's going to tell us, okay, how many standard deviations away am I? It's going to be about 1 point something, isn't it? Okay, so the first thing we need to do is you need to calculate that z-score. And we're looking for 21, right? So 21 minus the mean, or the average, over the standard deviation. That's
3 equals
4/3. That's 1.33 repeating, right? And I said, always round to the hundredths place. 1.33. Now, this table here, this is the z-score table. Okay, so what you're going to do is you're going to go there. And we had a z-score of 1.33, correct? So you're going to find 1.33 for your z-score. Okay? One side's negative, one side's positive. So make sure you're on the positive side. 1.33. Okay? So this right here gives us the tenths, right? 1.3. here's the hundredths. 1.30, 1.31, 1.32, 1.33. 0.9082.
We're 90.66%.
Right, 9082 I said? Now, what this table is telling us is the area to the left of that z-score. Okay? So let's say this was the 1.33. Okay? We got this value, the 0.9082. Okay? That's how much of the curve is to the left of that z-score.
Mr. McElwain? What number did you say you got again?
9082.
Never mind, I got it wrong.
So in our case, yep.
Why did we get, why?
Would 90.82% work?
Someone's asking a question, Andrew.
All right.
How did you pick 0.9082 out of all the other numbers that are right next to 1.3?
Okay. So these right here give us to the tens place. We're 1.33, right? These values up here are your hundredths place values. So like if I had 1.33, this is 1.30, this is 1.31, 1.32, 1.33, 4, 5, 6, 7, 8, 9.
Oh, that makes sense.
Okay. So now again, that value you find on the table tells us the area to the left of the z-score. Now, make sure you hold on to this one. If you lose it, come get one from me. So if you Google a standard normal probabilities or a z-score table, there's different ones out there. The one we're using gives us the area to the left. You can Google it, and you might find one that gives you the area to the right. We will be using the area to the left. So make sure if you lose this, come find another one from me. Okay? So, we said that gave us,
Mr. Mr. Page,
yep,
would for first part 90.82% work?
yep. Just make sure if you go percent, that percent symbol needs to be there. Okay, now, it says it gave us the area to the left of it. What's the area we were looking for? To the left of it, right? So do we need to go beyond that at all? No. That z-score gives us that area already. We're going to get to ones where we want to the right of it. That's our next one here. Okay. But if we're looking for that area to the left of it, that table is going to give us what we need. So the chances, or the probability that it takes a student at most 21 minutes is at 0.9082 or 90.82%. Now, my recommendation, just leave it as a decimal. So if you give me 90.82 and you forget your percent symbol, is that right? No. 90.82 without a percent symbol, that's 9,082%. Okay, so if you go percents, you need to make sure you write your percent symbol. Now, it's just an extra step. Why take that extra step? No reason for it, right? So just leave it as a decimal.
Can you ever ask us to change it to percent or to change it to decimal?
Possibly. Okay, just make sure to read the directions carefully then, right? Okay. So, same situation here. We still got that mean of 17 and a standard deviation of 3. Okay, but now I'm looking for at least 13 minutes. 13 is going to fall about here, isn't it? And when I say at least, that's the smallest value I could possibly want, right? So what am I going to shade to the left or to the right?
To the left. Wait.
Did you say right?
Yeah.
Oh, I thought you said left initially. Yes, to the right.
I'm not crazy.
What the heck?
Did that fall on 1, 2, or 3 standard deviations? No. So we have to calculate the z-score then, correct? What's my formula? What's it going to be when I plug my things into the formula? 13 over 3. That's going to be negative 4/3 or negative 1.33. Again, always round to the hundredths place. So, make sure you're on the proper side. We had a negative z-score, right? Negative 1.33. Negative 1.30123. 0918. Now, again, what area does that give us? To the left of that z-score, right? So this area of 0.0918 is right here, correct? Is that what I'm looking for? No. I'm looking at the area to the right. Now, this is where that whole idea of 1 comes in. Area under the curve is 1, right? And I want to exclude what? 0.0918. So how can I figure, how am I going to figure out the shaded area then? 1 minus that. Which gives me and again, you will have calculators. What's that?
How is it that it's the same number?
Okay, so let's think about that. What was the z-score here?
Just on the other side.
It's opposites of each other, right? Okay, and on this one, we were looking for the area to the left. This one, we were looking for the area to the right. Normal curve is symmetrical, isn't it? And doesn't it look like, I mean, my drawings aren't perfect, but it looks like the same amount of area is shaded, doesn't it? Yep. Questions on those two at all? Okay, let's go one more with that one. Okay, we still had that average of 17 or mean of 17, standard deviation of 3. But this time, I want to know what the probability is that it's at least 19 minutes to get to class. Not at least 19, same thing. At least 19. Here's where 19 would fall, right? About there? And when I say at least,
To the right of it.
the right. So we're going to use that same idea we just did with that last one, right? Calculator z-score, because it doesn't fall right on 1, 2, or 3 standard deviations. So 19 minus 17 over that 3, 2/3. What's my z-score if I round to the hundredths? 0.66 or 0.67? 0.67. 6 will tell us to round up, right? Okay, so then when I go to 0.67 on the table, do we need to look it up together, or can we just go look it up ourselves? Okay, 0.67. 0.7486. You guys agree? Is that the area that I'm looking for, though? No. That's the unshaded area, correct? So what do I do in order to get the shaded area? One minus that. 0.2514. Who's got a calculator? Double check my math. Yep. Okay. or 25.14%, right? Questions there?
Just,
I'll leave it up there for a second. Bud. Keep working. Okay. So, next one. A pizza parlor franchise specifies that the average amount of cheese on a large pizza should be 8 ounces, and the standard deviation only 0.5 ounces. What's the probability that the amount of cheese is between 7.1 ounces and 8.8? We always set up our curve first, right? Okay, we had that mean of 8. Standard deviation of 0.5, so 8.5, 9, 9.5, 7.5, 7, 6.5. Now, I'm trying to figure out when it's between 7.1 and 8.8, correct? What's the area that I shaped? Right in the middle there, right between the two. So now let's think about this. Figure out the z-scores. We're gonna be able to find 2 separate z-scores here, right? Okay. When I find the z-score of this and go to the table, what area is that going to give me? A little unshaded area, right? When I go to this one, it's going to give me this whole area. So how am I going to find the area of this then? Subtract. This is going to give me that whole area, right? And then if I just subtract that one, what's that give me in between? Okay. So we got to find 2 z-scores, find those areas, and then subtract the larger one from the smaller one. So let's go ahead, let's find that larger z-score, or that positive z-score first. That's going to be the 8.8, correct? 8.8 minus 8 over that 0.5, or 0.8 over 0.5. Anyone know what that would be?
1.6.
1.6. Okay, let's just calculate that other one right away. 7.1. So 7.1 minus 8 over 0.5, which would be negative 0.9 over 0.5, or
Negative 1.8.
those are my z-scores, right? Again, that tells us how many standard deviations we're away. 8.8. That's 1 point, another 0.6, right? 7.1, 1 plus a little bit more, right? Negative 1.8.
Hey, Mr. H,
Yep.
just a heads up, class ends early today.
Yep, and we're done at 9:28.
Wow.
I'm from pep rally this afternoon. Now, is there a 100th place? If you want to, just put a 0 there.
Oh, okay. I thought you said we had. I thought. we
Yeah,
did
yeah,
too.
that's fine. If you did one, just for the sake of the table, if it goes beyond the 100th place, round to the 100th, I should have said.
Oh, okay.
Yeah, quick question.
Yep.
Let's say we got an answer of like 5/3. Would we round that to 1.66 or 1.67?
6, 7.
Yeah, that's what I thought.
Yep.
I just figured I'd ask to make sure that my other answers were right.
Yep, always round to the hundreds. 6,666, that 6 tells us to round up, right? Okay, so now we need to find the area associated with those z-scores, right? 1.60, 0.9452. Double check me there. Okay, so negative 1.8 then, flip her over.
0.0359, I believe.
Okay, so the area, that one was just that unshaded area, right? And the 0.9452, that was this whole area to the left, correct? But I want to exclude this, correct? This minus this, correct? That'll get us in between. So anytime it's in between, you're going to have to find two z-scores and then subtract the one from the other. 9452 minus 0.0359, 0.9, 0.48. Come and double check. Isaac, plug it in for me, would you? Oh, yeah, that makes. It's Friday. 9 what? 9.3. Or if I was to change it to a percent, again, if you go percent, what do you need to make sure of?
Symbol.
Percent symbol. Go ahead, give that next one a try. I'll leave this one up here for reference. Once you get something, make sure you compare with your shoulder partner, see if you guys got the same thing.
Jenny, it's just,
What would you get for your first Z-score?
Well, I got 18 degrees, 0.001,
Yeah.
and 0.003.
What was it?
I just put it in.
Oh, yeah, it was. I was looking at the wrong one. You're right, you're right.
What do you get for your first?
I put 3.6.
That one I thought. Do you know about it? What were the numbers that is
Yeah, there, no.
So what was this and then board subtract
You say subtract 23. Okay.
Okay, set up your table, right? Set up your mean, standard deviations. And we're between 4 and 5.5, between. So what area do I shade? Between the two. Now, when I look at this Z-score right here, what's it going to be about? What would be the whole number part of that? 2 something, right? 2 point something. When I go to this one, 1, 2, negative 2 point something there, right? So keep in mind, not a bad idea to draw out these normal curves every time, right? It gives you a good idea. Make sure you're in the right area for those Z-scores. So let's go ahead, let's find the further right one. That was 5.5 for the score, right? Minus that mean over that standard deviation. What'd you get for that? With Z-score?
2.43.
2.33. Okay. Finding that other one, 4 minus the 4.8 over 0.3,
Negative 2.67.
negative 2.67. Again, once you find the Z-scores, find the areas associated with those Z-scores, right? 2.33, which one was it? What was the area
0038.
for
Oh, wait,
2.3?
no, it's the other one.
9901,
Yeah.
okay? Again, that's everything to the left of that Z-score 2.33, correct? I need to exclude that little sliver at the end, the end tail, correct? So negative 2.67, 0038. Okay, so that 0038 is just that little sliver right here, right? I gotta exclude that from the 0.9901. So, to exclude it, we subtract. Which gave me what?
0.9863.
And again, if I were you guys, I would just leave it there. Otherwise, 98.63%.
What?
Give me a second, but I'll walk you through it, okay? All right, questions from today? Not too bad, right? Okay. Monday, we'll do our last lesson. And it's kind of reverse thinking. I'm going to give you the area, you might have to find a Z-score. Or I'll give you the probability.
Last lesson for this year or
This year. So, questions from today?
No.
No.
You got 9 minutes. Z-score worksheet. That's what we need to work on. First four, you're just finding the z-score, that's it. The other ones, you're actually finding the probabilities. Okay. Did I give you guys those normal curve sheets at all yesterday?
Yeah,
Okay, wouldn't be a bad idea to have those when you work these out. That or you just gotta draw the curve yourself, either way.
You gave us a sheet?
I don't think I did.
I don't think so.
That's first period.
I was like,
Okay, I'll make sure to get some more of those and I'll get them to you guys too,
okay.
okay?
So we-
But, just draw the curve to give yourself a visual, right? Shade what you need to. Then find the area associated with that shaded area. So, use these last 8 minutes wisely and let's get to work.